This is Steve with Wallaroo AI, and today we're going to see how we can use the Wallaroo AI Universal Inference Platform to deploy our own LLMs using Llama CPP and powered by ARM processors. We're also going to see how we can monitor these LLMs and ensure a healthy production lifecycle for them. Starting off in our Python environment of choice, first we import our pip installable Wallaroo SDK, and then we go ahead and create a client connection to our installed Wallaroo instance and set the workspace that we're going to be using for this project. Next, I can use my upload model function to upload and package my model with the Wallaroo platform. This function takes the model name, it takes the file name of the model artifact. We tell Wallaroo what framework we're going to be using. In this case, it's Wallaroo's custom framework. And we also tell it what architecture we want to target, in this case, ARM. With Wallaroo, switching between different frameworks, architectures, and accelerators is as easy as switching a couple of arguments at upload time here. And now, when my model is packaged, it will automatically target that architecture and any accelerators that are specified. Now, the custom framework in Wallaroo allows me to customize what happens at model loading and inference time. And so if I go ahead and take a look at the main model.py file here, I can see it's a pretty lightweight file that implements a couple of classes. And two primary areas where I have control here are load model. You can see here I use Llama CPP and use my gguf to initialize my model object, and then my predict function. And you can see here I customize what the format for my prompt looks like and how it's processed by the Llama model. Once I've defined that, it serves as the input to my upload model function that we saw prior. And after a couple of minutes, my model will automatically be packaged and ready to be used in a pipeline for deployment. Next, I can define my deployment configuration for my model. Among other things, this allows me to specify how many CPUs and how much memory I want to power my model. In this case, we can see I'm attaching 10 ARM CPUs and 10 gigs of memory to this model. This is a fairly simple deployment configuration, but I can also specify more advanced things like GPUs as well as auto scaling here. Next, I can go ahead and build my pipeline, add my model to it, and then deploy it out with the deployment configuration that I specified. This will actually go ahead and pull the trigger on everything that we specified. It will provision the hardware in our deployment configuration. It will set up a load balancer and a web service to sit in front of my model, so at the end of this, I have a fully production-ready, scalable deployment. Additionally, because my model was targeting ARM hardware, at deployment time, Wallaroo will automatically make sure that the hardware that is provisioned matches that architecture. In this particular example, we're in GCP, which means that the Ampere processors available there will be processing this. And of course, this also generalizes to Graviton on AWS and Cobalt on Azure. Now that my pipeline is up and deployed, I can test it out with a quick prompt, which I ask it for some movie recommendations, which it gives me. And if I'm happy with this, at this point, I am fully in production in the cloud running on my ARM hardware with my LLM. And at this point, I have the URL for my pipeline that I can use for inference. I can send my prompts to this via post request and get my inference results back. And as this endpoint represents my fully self-hosted LLM, I can distribute it to any other users who want to make use of this LLM to build applications on top of it. Next, I can switch over to my Wallaroo Operations Center UI, which gives me a visual way to see all the work that I've done so far and manage these pipelines in production. And so I can see here the pipeline that I deployed. I can see the pipeline steps associated with it, the version history of my pipeline, as well as that external inference URL that I can pass along to any other developers here.